Hello everyone. Now we study about the addition, subtraction, multiplication and division of the floating point. First we study about the addition of the floating point. So we know 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. But when 1 plus 1 is equal to what? Regularly we know that 1 plus 1 is 2, but this is the binary addition. We perform here floating point addition of the binary number. So 1 plus 1 is 0 and we give carry to the next bit of the addition. So let's we see one example. So 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. But 1 plus 1 is 0. Carry 1. Now this 1 plus 1 is 0. And 0 plus 1 is 1. But here one carry is goes. So this carry is also right here. So I hope you get idea. 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. 1 plus 1 write 0. Carry 1. And we do cross check also. We know 1 plus 1 is 2. And how we write 2 in a binary form? 1 and 0. So first we write 0 here. And this 1 we take carry to the next bit. So again this carry 1 and this 1 is 1 plus 1 0 and 1 carry goes here, and now 0 plus 1 is 1 and this 1 is right as it is. Let's see one more example and we do cross check also. So this is the binary of the 14, this is the binary of the 1. And 14 plus 1 is 26 and this is the answer is also come 26. See here is the 16 plus 8 plus 2 is the 26. So I hope you all get the idea. So for the addition of the floating point, some steps are follow. First convert the given number into the binary number, then write the binary number in the scientific notation, then compare the magnitude of the exponent and make the suitable alignment of the numbers with the smaller magnitude of the exponent. Perform addition or subtraction. Normalize by the shifting the result of mantissa and adjust the result of the exponent. So let's start. First we convert the given number into the binary number. So we know all the steps. First write number and divided by 2. So here is 4, remainder is 1. Then again when divided 4 with 2, then quotient is 2 and remainder is 0, and again divide 2 by 2, this is now 1 and remainder is 0. So now 9 is equal to 1 0 0 1. We go from bottom to up. Now we want to convert floating point, means 0.75. This decimal number we want to convert. So as I told in previous video, write first floating point, multiply with 2, 0.75 multiply by 2, then the answer is 1.5. Write unit place number in front of the number. This is 1. write number which is before the floating point. Here now 1 is the before the floating point, so we write 1. Now which is the numbers present after the floating point, write them in 0.5 because after floating point only 5 is present. So write this 0.5 into 2. So this is now 1.0. So now which number is before the floating point, write them in front of the number. So here 1 is present, so write 1 and go. Now again we multiply 0 with 2 because after floating point 0 is present, so no any issue because any number multiply with 0, answer is 0. So now go from up to bottom. So now 0.75 is in the form of binary is 0.11. This is the binary form of the 0.75. So 9.75, this is the decimal number, and now the binary is 9, we write 1001 and 0.75 is 11. This is the binary of the 9.75. Now we want to convert 18.5625 into the binary. So first write integer number before the floating point. We find out the binary number, so divided by 2 for converting given integer number into the binary number. So this is the divided by 2, quotient is 9, remainder is 0. Again divided by 2, here is the 4, quotient is 1. Again divided by 2, 2 2s are 4, so remainder is 0. 1, 2 1s are 1, and remainder is 0. Go from bottom to up. So the binary number of 18 is 10010. Now we want to calculate 0.5625. So multiply the floating point with 2. So 0.5625 multiplied by 2, then the answer is 1.125. So before the floating point 1 is present, so write here. Now which are the number after the floating point, take for multiplication 0.125 into 2. So the answer is 0.25. The number which are present before the floating point is 0. Now again after the floating point 25 is present, so 0.25 into 2. The answer is 1.0. So this is 1. Now again not we multiply by 2 because 0 is come. So now go from up to bottom. So 0.5625 is in the binary is 0.101. So binary of the number is 10010.101. This is the binary of the given decimal number. So now our given decimal number we converted into the binary number. Now the next step we want to convert into the scientific notation. So we know the scientific notation is m into b raised to e. So what is mean by m, b and e? M is the mantissa, b for the base and e for the exponent. So we know the base of the binary number is 2. So we convert now the given number into the scientific notation. For that we want only one number in before floating point, which is our sign bit. So for that we move the decimal point at the left side. So how many times we move? 1, 2 and 3. Now when we move 3 times decimal point, then we get 1.00111. Why we do this? Because we want first bit is always our sign bit, and after which bits are the present, these are our mantissa. And how many times we perform movement? 3 times. We move decimal point 3 times in left side, so exponent is 3 and 2 is our base. So this is our scientific notation of 9.75. Now we want 18.5625 into the scientific notation. So again we take place movement of the decimal point up to 1 bit is remaining, which is our sign bit. So we move how many times? 1, 2, 3 and 4. We move 4 times decimal point, then we get our sign bit. So 101. This is our mantissa into 2 raised to 4, because we move 4 times decimal point in left side. So now the scientific notation also we write. Now for the addition or subtraction, always we want exponent is same of the both the numbers. So we have two choices. One, convert the 3 into 4 or convert 4 into 3. But the condition is also we know. For the scientific notation, we want one number before the decimal point is binary, which represent the number is positive or negative. If we convert 4 into 3, then our decimal point move at the right side, and two numbers are the before the floating point, which are not right way to write the scientific notation. So we convert the smaller number into the bigger, means we convert 3 into 4. So how we convert? We move the decimal point at the left side one time. So now 0.100111 into 2 raised to 4. So our condition is now satisfied. After the decimal point, binary number is present, and only one binary number, means only one bit is present before the decimal point. And now both exponent is also now the same. So we perform the addition of the floating point of binary number. So now we perform the addition. So when we perform the addition of the decimal, then what we get? 5, 2, 11, carry 1, 13, carry 1, 18. So when we do addition, then we get 28.3125. So let's we check. When we perform the addition of the binary number, we also get the same number or different. So here we write binary of the 9.75, which is here, and the next one 18.5625 right below. And now 2 raised to 4 is the same for both the numbers, so we write directly here. Now we know 1 plus 0 is 1. 1 plus 1, 0, carry 1. 1 plus 1, 0. 0 plus 0 also 0. And here 1 carries goes, because 1 plus 1, 0, carry 1. Now this 1 plus 0, 1, and 1 plus 1 is 0, carry 1. Now 1 plus 0 is 1, and 1 plus 0 again 1. 1 plus 0 is 1.1. 1. I hope you get the idea how to add them. 1 plus 0 is 1. 1 plus 1 0, carry 1. 1 plus 1 is 0 and 0 plus 0 is 0, but here one carries also goes. So 1 plus 0 is 1 and 1 plus 1 is 0, carry 1. 1 plus 0 is 1 and 1 plus 0 is 1, means directly we do here 1 plus 0 is 1. And so in this same way we perform the addition. And if we want to check, we write the correct addition or not. So here we see we perform 2 raised to 4. So we move our decimal 4 times. Now right side, when we perform movement of decimal in right side, that time one exponent is decreases 1 by 1. So we go here 4 times front. This is for only a cross checking our addition is true or false. In exam not perform write the steps of the movement of the decimal point at the right side. This is sufficient for the answer of the addition of the binary number. But if we want to cross check, then let's check 1 2 3 4. Now our decimal point is here. So when we move 4 times right side, then we get 1 1 1 0 0.011. So we know after the before the decimal point we add on just. So here we get the addition of the binary bits are the 28. Let's see, 16 plus 8 plus 4 is 28. So 28 is right. Now after the decimal point, how we calculate? 0 into 2 raised to minus 1 plus 0 into 2 raised to minus 2 plus 1. Here is 1. 1 into 2 raised to minus 2 plus 1 into 2 raised to minus 3. So this is also right. We get 3125. So our answer is correct. So I hope you all get the idea about how to add the floating point binary number. Now we see how we subtract them. So now we see how we subtract the floating point. So again we know 1 minus 0 is equal to 1. 0 minus 0 is equal to 0. 1 minus 1 is equal to 0. This is the simple, but when it comes 0 minus 1, then this is the critical situation to find out the binary number subtraction. So what we do, we here get borrow from the previous bit, means we take one borrow here, and now this is the binary of the 2. Am I right? So 2 minus 1 is equal to 1. So for that we perform 0 minus 1 is equal to 1. So we perform 0 minus 1 is equal to 1, and we give for that we give take borrow from the another bits. So this is the borrow bit. In addition we take carry, and in subtraction we take borrow. So when comes 0 minus 1, that time this is equal to 1 and borrow for the previous bit. So first we see simple example of the subtraction, then we move for the floating point. Now here starting is start from 0 and 1. So what we learn in this basic concept, when 0 and 0 minus 1 is come, then first take borrow from the previous bit, means now here is 1 0 and this bit give the borrow. So now this is the 0. because the 1 is go from this bit to the next bit. Now 1 0 we know 1 0 means 2. Of the binary number of 1 0 is 2. So 2 minus 1 is 1. So as I say 0 1 1, and now the 0, now this is not a 1 consider because this bit give borrow to the next bit. So now here only 0 present. So 0 minus 0 is 0. Now again 1 minus 1 is 0 and 1 minus 0 is 1. So let's we cross check our answer is right or wrong. So this is the binary of 12. So the 1110 is the binary of the 14. 0101 is the binary of 5. So 14 minus 5 is 9, and our answer is also come 9. This 0, 2, 4 and 8. So 8 plus 1 is 9. So our answer is correct. We see one more example. Here also 0 minus 1. So we want borrow here, but for giving borrow previous bit is also 0. So it not give borrow to the next bit. So again he requested for the previous bit to give the borrow for them. So now 1 give borrow to the next bit 0. So now here 1 is converted into a 0. Now here is borrow is come. Now 1 0 is here. So 1 0 means 2. What this bit is do? From 2 it take only 1 and give 1 for the next bit. So 1 0 is 2 we know. So this bit perform. So this bit give 1 bit to the both the bits. So now here borrow is 1 is come. Now this 0. So 1 0 is 2. 2 minus 1 is 1. Now here is only 1 present. So 1 minus 0 is 1. Now here 0. 0 minus 1. Again we want borrow from the previous bit. So now this 1 give borrow for the next bit. So now 1 0 means 2. 2 minus 1 is 1. Now 0 minus 0 is 0. These all are the borrow. I hope you get idea what we do here. First we do 0 minus 1 is not possible. So for that we want 1 borrow. But so he requested for the previous bit. Give 1 borrow. But previous bit is also 0. So 0 has no capability to give borrow for the next bit. So he requested for the 1 to give borrow. So 1 has capability to give borrow. So he give borrow to the 0 and itself converted into a 0. And now here 1 0 is come. So 1 0 is the binary of 2. So in binary form we don't want 2. We want only 0 and 1. So what this 0 bit done, he share 1 bit to the next bit, next 0. So now 1 he keep 1 to the for itself and share 1 bit to the next. So now he also get 1 borrow, and this bit is also get 1 borrow. So this sharing of these 2 bits, how we do, I hope you get idea about this. So now 1 0 is 2. So 2 minus 1 is 1. Now this 1 and 0. 1 minus 0 is 1. Now here only 0 is present. So again 0 minus 1 is not possible. So he requested for the previous bit for the borrow. So 1 has capability to give borrow. So he give 1 borrow to the next bit, and itself converted into a 0. So this 1 0 means 2. 2 minus 1 is 1. Now so we take same example of the previous one for the subtraction. So when we normally subtract the decimal numbers, then we get 8.8125. Let's see we get same decimal number, same answer or the wrong answer. Let's check. So 1 minus 1 0. Now 0 minus 1 not possible. We want to borrow. We requested for the 1. Now it give borrow to the 0. So now this 2 minus 1 is 1. Now again 0 minus 1. So we again want to borrow. So we requested 0. But 0 has no any number to give borrow. So he requested to the 1 to give borrow. So 1 now give borrow and converted into a 0. Now here is the 2 1 0. This bit share the one bit with the another next one, means one use for itself and one share to the next bit. Now 1 minus 1 0. 1 minus 1 0. Here this 1 minus 1 is 0. Now 0 minus 0 0. 0 minus 0 0. Now 0 minus 1 is not possible. We take borrow from the previous bit. So now this is the 2. 2 minus 1 is 1. Now here 0 is remaining. 0 minus 0 is 0. And here 2 raised to 4. Because this example is same as the previous addition example. This one, and we same procedure, means we converted into a scientific notation. We equate the exponent of both the numbers, make it equal exponent, and then we perform addition or subtraction. So again when we cross check the answer, then the same answer is come here. So I hope you all get idea how to add and subtract the binary numbers. Now the floating point multiplication. Let's suppose first number is x is equal to mx plus into 2 raised to a, and second number is equal to my into 2 raised to b. Then when we multiply them, means x into y is equal to mx into my into 2 raised to a plus b. Means multiply the mantissa into 2 raised to, add the exponent of the both value. Let's we see with the help of the example. So in this example we consider the numeric value is the mantissa, e is the base, and 4 is the exponent. Same here, this is the mantissa, this is the base, and this is the exponent. So first step, we add the exponent here. Let's first see how which are the steps for the multiplication. Compute the exponent of the product by adding the exponent together. So this is the first step. So we add the exponent. 4 plus minus 2 is equal to 2. Now the second step, multiply the mantissa, means this is the mantissa. So 0.200 into 0. So multiplication is 0.08, because 0.2 into 0.4 is equal to 0.08. And how many zeros are after the floating point? These are the invalid, means no value of this 0. If this 0 come front of the integer, then they have value. So here 0.08 is the multiplication of the mantissa into e raised to 2, because now when we add the exponent of those integer, then we get 2. So the last step of the multiplication is normalize and the round of the final product. So this is also correct answer, and if we write 0.8 into e raised to 1, because the floating point we move at the right side, and when we move at the right side, when we decrease the exponent, and when we move for the left side, then we increase the exponent. So we see one more example. First step, add the exponent of the bases. So here the exponent is 5 and 2. So 5 plus 2 is equal to 7. Second step, multiply the mantissa. So 9.04 into 5.5. First simply do multiplication. 904 into 55. So this is come 49,720. Then count how many numbers are present after the floating point. Total means this 2 number, and from this 5.5 1 number. So 1 plus 2 3. So give the decimal point after 3 integer. So 1 2 3. So this is the answer of the multiplication, 49.720. So 49.720 into 2 raised to 7, because our base is both side 2, so here also 2. Now this is the answer. This is also correct, and when we normalize or the round off the answer, then we write here also 4.9720, and now we move for the left side, then we increase the exponent. So 2 raised to 8. So this is the answer. So division is also the same as the multiplication, changes little b. Let's suppose first number is mx into 2 raised to a, and y is equal to my into 2 raised to b. So in multiplication we add the exponent, but in division we subtract the exponent, and in multiplication we multiply the mantissa, but in division we divide the mantissa. This small changes is here. So let's we see what are the steps for the division. So first is compute the exponent of the result by subtract the exponents, divide the mantissa and divide the sign of the result, and last one is normalize or the round off the result value if necessary. So let's we see with the help of the example. So all the steps are the same. First subtract the exponents as per our steps. So minus 5 minus 3. So this is minus 5 plus 3 is equal to minus 2, because this minus now plus. So this is our answer of the exponent. Now we second step, so divide the mantissas. 3 divided by 0.2, because no value of zeros here, because all are the zeros after the floating point and after the integer. So this 0.2 is equal to the 0.000. So the answer is 4 point, not 0 point. Here answer is 4.3871, and for our normalization or round up the result, for that we move the decimal point at the left side. So now this is 0.43871 into e raised to minus 1. So we see one more example. So first step, subtract the exponent minus minus 4. This is the plus 4, so that's why. So this minus 2 minus 4 is equal to minus 6. Now second step, divide the mantissa. So 0.4 divided by 0.2 is equal to 2. So now we write the result, 2 into e raised to minus 6, and we normalize, means if we want the floating point, then we write 0.2 into e raised to minus 5, because this is now in the form of 2.0 into e raised to minus 6. So if we move this floating point at the left side, that time our exponent it increases, means plus 1. So minus 6 plus 1 minus 5. So I hope you get idea about how to perform addition, subtraction, multiplication and division of the floating point. Thank you.